Alright, in this video I want to show you how to find what's called the inverse of a matrix because it's going to help us use or learn how to use our final method for solving systems, which is solving systems by inverse equations. So first of all, what is the inverse of a matrix? And let's pretend we have a matrix and we'll call it by the letter A. Okay, and then the inverse of a matrix, the symbol for the inverse of a matrix is A with this little -1 right here. Okay, this right here means, or you read that as A inverse, or the inverse matrix of A. Okay, inverse is a fancy word for opposite. So for example, when we're talking about math operations, the inverse of adding is subtracting. The inverse of multiplying is dividing. The inverse of squaring something, or sorry, the inverse of square rooting something would be squaring something. The inverse of multiplying by a matrix the inverse of a matrix is multiplying by its inverse matrix. If these things get multiplied together, what you end up getting is you get something called the identity matrix. Okay, the identity matrix looks like the following. It basically looks like a bunch of ones along the diagonals, and then everything else would be zero. Okay, if it was a 3 by 3 identity matrix, it would be a bunch of ones along the diagonal, and then everything else is zero. Okay, these are both identity matrix. What's special about the identity matrix is that when you multiply any matrix at all by the identity matrix, you get the same thing that you started with. So let me give you a real simple example. Let's suppose we had the matrix 1, 2, 3, 4, and we wanted to multiply it by the identity matrix. First of all, let's just verify this is possible. That's a 2 by 2, and that's a 2 by 2. So these numbers match up, and these will be the new dimensions. So we're going to have a 2 by 2 as our answer. Okay, how do we multiply matrices? Matrices, I should say. So this is first row, first column. That's the first row, that's the first column. 1 times 1 is 1, and 2 times 0 is 0. So 1 plus 0 just gives us 1. Okay, this right here is the first row, second column. So here's the first row, here's the second column. 1 times 0 is 0, and 2 times 1 is 2. So 0 plus 2 gives us 2. Okay, then we have below that we have second row, first column. Here's the second row, here's the first column. When you multiply those, you get 3. When you add them after multiplying them, and then finally second row, second column, you get 4. So notice we get exactly what we started with. That's what's interesting about the identity matrix. Here's the other thing about inverses. There's two other things to know. First of all, we said that order typically matters when you're multiplying by, or you're trying to multiply matrices. Order matters. For example, if I'm trying to multiply a 2 by 2 times a 4 by 2, I can't do that because these numbers don't match. If I switch the order, if I do 4 by 2 times 2 by 2, now I can do this because those numbers match. The exception to this, the only time that order doesn't matter, is when you're multiplying inverses. So not only does inverse times A equal the identity, but A times its inverse in that order will also equal the identity. Okay, here's the last thing to mention. How can we know, because this is the second question, how do we know if an inverse actually exists? And the answer is if the determinant does not equal 0, it's going to have an inverse. So if the determinant is not equal to 0, the inverse does exist. Okay, if the determinant does equal 0, then the inverse does exist, and we're going to have one of those cases like we talked about before, where you have either infinite or no solutions. So now that we know somewhat what an inverse is, it might not be entirely clear in your mind, but at least we have a vague sense. Now that we know what it is and how to tell if it exists, I'm going to show you how to actually find it. Okay, it's kind of a three-step process. So we'll look at a matrix here, and you have to do three things. You have to find the determinant, because remember the determinant is what tells us if it even exists or not. And then you have to put the determinant under the number 1. So 1 under, or 1 over the determinant I meant to say. Okay, the second thing we have to do is we have to switch the order of the first diagonals in this matrix, and I'll show you how to do that in just a second. Then finally negate the signs on the second diagonal matrix. So let's do that. First step right here is we'll find the determinant of this matrix, and DET just stands for determinant. Okay, so the determinant, remember, is first diagonal multiplied would be 0 minus the second diagonal. 5 times 1 would be 5. 0 minus 5 equals -5. So our inverse, let's pretend that was inverse A. We're just picking a letter to call it A. Again, the way that we symbolize the inverse is A with that little -1. That means A inverse. Okay, so the inverse is going to be 1 over the determinant, and we just found the determinant was -5. So I'm going to put that right here, 1 over the determinant. And then so that's the first step. Second step says switch the first diagonals. switch the first diagonal. So these two, 1 and 0, are the first diagonals. If I switch them, they become 0 and 1. So that's what I mean by switch the first diagonals. And then the final step is negate the second diagonal. So these two, the 5 and the 1, are the second diagonal. If I negate them, that's a positive 5. Negate means change the sign. So if it's positive and I negate it, it becomes negative 5. And similarly, the 1, if I negate it, it's positive 1, it becomes negative 1. So this right here is now the inverse. Okay, let's test to see if that's actually the case, because we said that when we multiply inverses together, they should equal the identity matrix. So let's put this, I'm just going to clear off this thing that I boxed off here. Let's put the A matrix right next to it and multiply them together. And I'll leave the second multiplication to you as an extra thing if you want to do it, but I'll at least show you A inverse times A. And again, if this equals the identity, that's a good sign. That means we're doing it correctly. Actually, before we do that, one thing I want to mention too, notice that negative 1/5 outside, I'm going to save that till the very end. So I'm going to put the negative 1/5 right here. That's going right here. And the first thing we're going to do is just get this thing by multiplying this 2 by 2 matrix times that 2 by 2 matrix. Okay, so I'm just rewriting the matrix A right there, 1, 5, 1, 0. And let's go and do our multiplication like we've done before. So this right here is first row, first column. First row right there times first column. 0 times 1 is 0. Negative 5 times 1 is negative 5. You add those to get negative 5. This right here, first row, second column. So there's the first row, there's the second column. 0 times 5 is 0. Negative 5 times 0, also 0. We add them to get 0. Okay, this right here, second row, first column. Here's the second row, here's the first column. Negative 1 times 1 is negative 1. 1 times 1 is 1. Negative 1 plus 1 is 0 again. And then finally, our last entry here, second row, second column. Here's the second row, here's the second column. That's going to be negative 1 times 5 is negative 5, plus 0 is negative 5. Maybe you can see now why we kept that out front, because now when you distribute this inside to each thing, that's called scalar multiplication, by the way. When you distribute that inside, negative 1/5 times negative 5, both of those negative 5s become 1, and those are 0, and there's the identity matrix. So that's how we know that we did it correctly. We could also test the other direction. So try to pause the video and see if you can find the inverse of number 2 as well. Okay, so let's go through our steps again. Okay, remember, I know it's about to scroll off the page, but you can kind of screenshot that if you want to see what those 3 steps are. It's going to be 1 over the determinant, switch the first, and negate the second. So let's do that right now. So 1 over the determinant. First thing obviously would be to find the determinant. So that's going to be 8 times negative 1, which will be negative 8, minus negative 12 times negative 5 is 60. So negative 8 minus 60 is negative 68. And that is our first part of the process. We call the other one A, so let's call this one B. So B inverse is going to be 1 over the determinant, which we just found, so that's going to go right there. And then inside here, we're going to switch the first diagonal, so switch 8 and negative 1. And then secondly, we're going to negate the second. So that's a negative 5. If you negate negative 5, it becomes positive 5. That's what it means to negate something. Just change the positive or negative sign. If you negate negative 12, you get positive 12. And here is our inverse right there. In the next video, I'm going to show you how to use the inverse to actually solve matrix equations. So hope to see you there.